Hello everyone. In this session, I'm going to discuss about to form or to construct a parse tree and identifying whether a given string is accepted or not by the given grammar. Either it can be followed a top-down approach or a bottom-up approach. So before discussing about the top-down and bottom-up approaches for the given grammar, whether a string is accepted or error, so first we should make the grammar which is accepted by the top-down approaches. So to apply any top-down approaches for the given grammar, the grammar should not be ambiguity and should not consist the left recursion. So before entering into the top-down approaches techniques, first I want to discuss about how a left recursion is identified, whether in a given grammar a left recursion is available or not, and if it is available, how this left recursion will be removed from the grammar. So let me discuss how the left recursion will be removed from a given grammar. So first of all, let's discuss what is left recursion. So a grammar can be said it consists of a left recursion if it has a non-terminal at LHS side and starting of the RHS side consisting of the same non-terminal, then we can say it consisting of a left recursion. So top-down processing methods cannot handle the left recursion grammar. So before applying any top-down approach to find out a given string is accepted or not, first we have to remove the left recursion from the given grammar. Then the grammar is ready to apply any type of the top-down methods. So here we have one example. Suppose E derives E plus T. E derives E plus T. So a non-terminal at the LHS side is E and the non-terminal at the RHS side starting, immediate RHS side, both are having the same non-terminals. Then we can say this grammar is in left recursion. Now we have to rewrite this production by removing the left recursion, then only we can able to apply the any type of the top-down parsing methods of this grammar. So here I have taken one example, that is A derives A alpha. A derives A alpha. So A is a non-terminal and here A is a non-terminal. Both are the same non-terminal, same at LHS side and immediate RHS side, so that we can call it as the immediate left recursion or direct left recursion. So in such type of grammar or such type of productions cannot be used in the any method of the top-down parsing. So that if the grammar is in such a way, first of all we have to remove the left recursion from the grammar and then we have to proceed for the any methods. So for this we have to follow. So the given production if is in the form of A derives A alpha beta. So here alpha beta comes under the terminals, and whereas A and A comes under the non-terminal. So suppose for example, if the given grammar is in the format of A derives A alpha beta, then we can rewrite it by removing or eliminating the left recursion. So for this production, after eliminating the left recursion, we have A derives beta A dash and A dash derives alpha A dash and epsilon. So now you can observe same this production only, just we have rewritten into the two productions, splitted into the two productions to eliminate the left recursion, So it can be, now you can check A is deriving beta. So left recursion is not there in this production, and A dash derives alpha. So here also no left recursion is available. So like this the given grammar should be rewritten and the meaning should not be changed. For example, you can check here what we have. A derives beta A dash. So in the place of A dash, if I substitute nothing but A derives beta, in the place of A dash, I can substitute so A dash is going to be deriving alpha A dash, or A dash is going to be deriving the epsilon. If I replace epsilon in the place of A dash, what is the meaning of this production? So A is only deriving beta. What else we have? So A derives A alpha and A derives beta. Actual production is this one. I have written in a clear manner. So if I replace A dash with the epsilon, then what A is deriving? Beta. What exactly we have in the given production? Suppose if in the place of beta A dash, I am going to be epsilon is there, alpha A dash is there. So in the place of A dash, if I am going to be replacing beta, in the place of A dash, I am going to be replacing alpha A dash. Alpha A dash. So what it is going to be having? So alpha A dash. Again A can be replaced with alpha A dash. Again A dash can be replaced with alpha A dash, or else again A dash can be replaced with epsilon. So that we have A derives. So how many times A dash is going to be deriving, that many times we can replace with either A dash or we can replace with epsilon. So the meaning of the production does not change even though we have rewritten this by eliminating the left recursion into these two formats. Let's see one example for the clear understanding. So consider this example. E derives E plus T, or T, F derives T into F, or F derives. So I'll write one statement by one statement here. So first we'll see E derives E plus T and E derives T. So now checking the first production. First we'll check with the first production whether it is consisting of a left recursion or not. So here you can observe E is directly deriving the E. So this is consisting of the left recursion, and E derives T. E is the different non-terminal, T is the different non-terminal, so it is not consisting of any left production. So we can use this production as it is. So I am removing it. Now we have this production where it is consisting of left recursion, so we have to eliminate it. Actually, what the formula we have to use? A derives A alpha or beta. A alpha or beta, so that the first production is like this. The first production is like this. So A derives A alpha beta. So same in this procedure the grammar is, so that we can have A derives beta A dash, A dash derives alpha A dash or epsilon. So the grammar is in this format. We should get this grammar into this format. So now you can check alpha is equal to E plus, alpha equal to E plus, so here A is common, so that which is alpha? Here E is common, so which is alpha? Alpha is equal to plus T and beta is equal to T, that is slash T is there. So this is the beta slash T. So now we can rewrite like this. So E derives, what is beta? T, E dash, and E dash derives what we have to write? Alpha. What is alpha? Plus T. Plus T, E dash or epsilon. T, E dash or epsilon. So this is what we got is. Now you can check. So we got this from the this formula. So now you can check E derives T, so no left recursion. E dash derives plus T E dash, so no recursion. So here epsilon is compulsory. As per the rule of the given formula, you have to write the epsilon compulsory. So now here you can check E derives T E dash derives plus T E dash slash epsilon. So now we'll see for second production. So second production is T derives T into F slash F. So now consider here TT will be represented as A, and this will be represented as alpha, and this will be represented as beta. So now we can write it as T derives beta T dash. So beta is nothing but here F T dash, and T dash derives alpha A dash. So alpha here is into F T dash or epsilon. So the given second production will be written as T derives F T dash, and T dash derives into F T dash and epsilon. And coming to the third rule, that is F derives E and ID. So here we have F and here we have open brackets. This production does not consisting of any left recursion, so that we can use the production same as it is. So here I have written the grammar after eliminating the left recursion. So from the three productions, among these three productions, first two productions consisting of the left recursion. So after removing the left recursion, the two productions will become the four productions, and the last production does not consist of any left recursion. So we can use that production as it is. So here it is actually the grammar which is after elimination of the left recursion. Now this grammar, whatever we have consider the grammar after eliminating the left recursion, that grammar actually we can use for applying any type of top-down approaches. Other than this grammar directly we cannot able to use it either for the applying any top-down approaches. The grammar should not be consisting of ambiguity, and should not consisting of left recursion, and should not consisting of left factory. Then only we can use that grammar for the application of any top-down approach methods. So this is the example for the removal of the left recursion. So next top-down parsing aate. So actually the parsers are two types, that is as before only I have explained that the parsers can be constructed by using the two different techniques, that is the top-down approach and the bottom-up approach. Again top-down parsing has been divided into two types, that is the backtracking method and without backtracking method, or we can call it as the predictive parser. And bottom-up parsing we are having the shift reduce parser, LR parsers, operator precedence. Again LR parsers can be used by using the SLR, CLR and LALR. So in next class we will discuss about each and every technique in detail with an example. Thank you.